Hello everyone, welcome back to the Qubit Factory. As I threatened in the last episode, I have turned off the game audio. No music, no sound effects. It was catchy for a bit, but very repetitive, so I'm listening to my own music, which you can't hear. If you want to hear music, you're invited to turn yours on. But if you don't, you can just listen to my voice atop a sea of silence. What is it with all these awards? Okay, complete various levels. Okay, whatever, just achievements. Oh, there's a bonus level here. What? And okay, I don't think I can do this level right now. I don't know why they're allowing. Yeah, forget it. Why are you allowing me to click here, man? Okay, fine. Oh, there's bonus levels in some of these, but not all? Interesting. Huh. Okay, well, let's keep doing the classic ones. The last episode, I mean, I'm recording this like 20 minutes after I recorded the last one, so I haven't heard any feedback about what I misunderstood about this one. I think what I implemented was correct and should have solved the puzzle. Well, I got a correct solution. I got multiple correct solutions, and then I tried to combine them into an even more correct solution, and it should have worked, but it doesn't, and I don't know why. But let's move on to this one. I've just been informed that the last shipment of bit wires that we received are faulty. They cannot be crossed over one another without danger of short circuit. Maintaining a safe working environment is of paramount importance to all of us, so I need you to find a way for our factories to remain operational without explicit use of line crossings. Okay, so this is a layout puzzle. And I can't delete these either. Okay, so send bits from A to D and from B to C. Oh, is this like... This is like an XOR thing? You, obviously, like, the simple approach is this and this, but you can't. Funny, they didn't even actually implement the requirement that you can't cross wires. They just don't give you space to do it. Okay, whatever, man. So I think, generally speaking, this is like an XOR thing, where you say... You compute, like, Y, which is A XOR B. And then if you XOR that with B, you get A back. And if you XOR that with A, you get B back. But how do I have access to 3 channels? No, of course. I can't have access to 3 channels. But I can compute A XOR B, and that gives me Y, right? And then I can throw away either of A or B and reconstitute it from the other one. That's the joke. This is a... there's a programming trick that there's no reason to ever use this, and there never was a reason. I don't know. I mean... So, like... Suppose you have 2 variables, A and B, right? I guess it's not true that there was never a reason. In the extremely resource-constrained early days of computer programming, maybe there was a reason to do this. But you have two memory locations, A and B, which store numbers. And for some reason, you need A to store what B has, and B to store what A has. Very similar to what we have here. If... a simple approach that would be used these days is to, like, you know, in a language like most languages do that have easy access to tuples and where memory is cheap, you could just say, like, B comma A equals A comma B. That would be like a Python approach. And the compiler would swap them for you. Or the runtime would write code that would swap them at runtime. If you didn't have access to tuples, you could use a temporary variable. Call it Y. You say Y equals A, assign to Y what's currently in A, assign to A what's currently in B, and then assign to B what's currently in Y. And you swapped them using this temporary variable. But suppose you can't afford a tuple. You can't afford a third variable. In that case, what you can do is store the XOR of A and B in A, and then store the XOR of that in B, the XOR of those two things with each other in B, and then XOR... Anyway, so you end up with just like 3 XORs. You can swap 2 things, and that's what we're going to do here. It very closely mirrors that idea. I mean, I think it just looks like this, right? I don't even have to... I just know there have to be 3 XORs, and these are the only 3 I can do, so this must be right, without thinking through what specifically I'm actually computing. Yeah. Use 3 or fewer control gates. Yep. I mean, how could you use more? I don't know. Phew, you managed to keep things operating smoothly and safely until the replacement shipment of bit wires arrived. It's a good thing, too. Factory accidents involving wayward bits are terrible for PR. Great. We've just received our first, I imagine, shipment of multi-control devices from a new supplier. Ooh. Each device has 3 channels that can enact a controlled inversion. Boy, this is like somebody was paying you for using long words here. Of a target bit. Or at least they should, but many appear to be defective. I need you to design a test for defective channels in these multi-control devices. Use the bottom right R button to change the starting device if needed. So, okay, so R I think I found before, like, generates new random layouts and test cases. So what am I supposed to do here? Am I supposed to press R until... Is this teaching me about pressing R, which I found out by accident earlier? Or am I supposed to do something else? Devices take as input 3 control bits. Top. And a target bit. Bottom. These are the... Okay, yeah. From bottom to top control channels. Output a 1 if the channel implements... What are you saying? If the channel implements a controlled inversion of the target bit. Okay, we're supposed to get 10. Okay, what? There aren't any inputs. I'm just supposed to produce outputs. Output a... They take as input 3 things. Output a 1. So these are the 3 control channels. And we're supposed to output a 1 if that channel implements a controlled inversion of the target bit. What do you mean a controlled inversion? Are you high? So I think, okay, this is a device we're supposed to build, I think, a machine that can test whether an arbitrary configuration of these gates, what it does, right? And so the expected output for this is 1, 1, 1. And then I think after I output 3 1s, they're going to give me a new one of these things, but leave my machine in place and test me again. So is that true? Let me make sure I understand that. Like, is that what you want? If I just always output nothing but 1s, what's going to happen? I think these will succeed, and then it'll give me a new one of these to test. And then, of course, my machine will fail. So that one was correct. And then it reset, gave me a new machine to test, but left my... Okay, got it. This setup was confusing. This wording and this picture, I could not understand what they were asking of me. So, what do you mean a target bit and a control bit? So this doesn't invert any of them. This, I mean... There's... If the channel, what is a channel? Because, like, okay, what comes out of here is total useless junk, right? It's just what was put in to this side. So I think what I'm supposed to do is like feed in 100 and see if that flips the bit. Like I'm supposed to discover the not status. There's another word for that. The attitude? I don't know. Of these three possible inversion gates. And I assume each of them behaves oppositely in the 0. Let's find out, actually. Oh, gonna have to put one here as well. So in the 0 state, this is gonna flip, right? No. So like if I feed a 1 in, it's going to leave this alone, right? Yeah, what do you mean a controlled inversion? What is wrong with you? Could you explain this? R, no. C? Sure, whatever. Briefing. What does it mean? That is not a problem description. So, okay. Let's just say I always feed zeros into this, right? No. We always we can always put zeros in here. That's fine because we're testing whether something's inverted. But let's try putting alternating thingies in here, right? So just so I can test what they do. So in this mode, I think what this means is like these guys are always off. So I guess like the... In all of the random configurations that it gives me when I press R, I should interpret the 0 state of these control things to be neutral. It won't do anything. Even though, I think, it's possible, if I wanted to design one that works the other way. I could say in 0 mode, toggle. Right? And in 1 mode, don't toggle. I could do that. But they haven't done that. They've put them 0 mode, don't toggle, 1 mode, something. And your job is to figure out the something, I think. So we have to test sending 100, 010, and 001. I think I got those right. But sent the three different ways that you could send a single 1 bit into this system. And starting with the top, produce output indicating whether it works or not. So, can't I just feed those 3 inputs, or those 9 inputs in? Like, create 3 different lines, each of which has the 3 inputs I need, sequences of inputs, and send 3 zeros through here? And it should all synchronize properly, right? I think. Yeah, I mean, it seems kind of straightforward, now that I think I understand the problem. I don't need the control bits when I'm done with this. And I don't think I need any synchronization even, right? I just need to... I've already produced like 001 before. I just need to do something similar, but... Okay, so let's have one... Well... Okay. What is the goal, by the way? What is my design goal? None. You just get a star. Okay. So... to the left, I want to send a 1 first. Yeah, this is right. That's the way to do it. So split this into 3 fresh bits. Oh, there is going to be a conflict here, isn't there? That's fine. I can address that. This is not working. I have plenty of space horizontally. So split this. I want to produce 1 and then 0, 0. And that's what's going to go to the top wire. So that's a... There we go. I think I'm, like, clueless? I'm stupid? Maybe more like that. So these things, I believe... Well, I guess I don't even depend on that now, do I? So that'll produce a 1. No, I am depending on it a little. So... Oh, no, this is backward, because this actually is slow. Okay, well, let's just say yours being set to 0. So these will both arrive here at the same time. But my understanding is these guys give... Well, let's check the handbook. They give priority to... Priority is given clockwise from the output direction. So it should be that this one is preferred before this one. Am I right on that? Nope. Why didn't they arrive at the same time? Oh, the one that is further clockwise is given priority? I thought you meant the one closest to it in clockwise order, but okay, fine. Oh, and I only want one of these. So we're testing this one. Oh, well, I guess this one, actually. So they all make it in here, but then they're going to get... Oh, they're going to get backed up here, aren't they? If I just let them all flow in at arbitrary orders. So I should be throwing in a sink, like... here and here-ish. Maybe. Well, that's not going to work. It'll ensure that the inputs go into these things at about the same time. But that's not actually what I want. Because these crossings are problem points where we're going to have buffers build up. If I let all three... The problem isn't that I need the 3 inputs for the first test case to go in at the same time. The problem is I don't want any inputs for the second test case to go in until the ones for the first input are done. So... I think these sinks are fine, But I need another mechanism to make sure nothing gets to this sink until we're ready for an input. So, like, this output won't just get trashed, is my idea. Instead, the outputs will be collected here. And one thing we're going to do with an output is actually output it. But we're also going to send a control signal saying, okay, it's fine to let the next guy in. So what I want then is a sink like here between, and I guess I'm going to want, as I had in a previous thing, no, not this, 1, 0 to start things off. Like that. Well, we can do a little better, right? Take up a bit less space. So we're going to send this. This is the bit that actually gets to here. And this is the timing bit that we can just throw away. And so then I just need 2 more 3-bit generators, one to go here and one to go into this sink. And I have plenty of space for that. So this one I want to produce 0, 1, 0. That's what's going to go into here, into this second one. How is that going to be generated in the correct order? Zero, 1, 0. I need a 0 to get there first. That's you, I guess. Maybe I'm looking like this. So that 0 should get there pretty fast. This 1 will be slower because it has to go through something. And this 0 will be slower because it has to go the long way. Is that right? Nope. Yes. Oh, only 1, please. Zero, 1, 0, successfully output. Okay. So then we just need 0, 0, 1. Which might be the easiest of all, I hope. No, stop. Because I can just make the 1 take the longest path and also be the only one that goes through. Well, I guess its path is no longer than this one, but it should get there more slowly, right? God dang it. Only 1, please. Yeah, 0, 0, 1. God, how did you get back to multiples? I thought I had you on 1. Oh, I deleted it and re-added it. That's why. Okay, so we're producing what I wanted to produce. Let's see if the timings all work out properly. Yeah, this is great. Oh, I shouldn't merge these. I should. I'm like high as a kite with what I did over here. Okay, this is all crazy. These are all supposed to be deleted. This is supposed to be what splits, and some of it gets output. So some of you goes out, and some of you goes onto this thing. And then we also have a creator feeding the first starting bit in here. I didn't check whether we actually produced the right thing here, and since I have the sound off, it doesn't... how bad would the sound be? Oh, that's the music. The sound doesn't seem to do anything? It didn't make a noise when that happened? But we're outputting a 1, so this is correct. I hope the previous 2 were correct. Great. Okay. So I choose to believe that we have done this perfectly. Nope. Okay, what is wrong? What have I misunderstood the problem? The problem is not stated very clearly, so that wouldn't be a shock. So I'm taking as a given that in 0 mode, all of these are pass-throughs. And in 1 mode, this... Okay, so we're already wrong. We did something wrong here. Oh, it says from bottom to top. I read top to bottom. Okay. Well, fine. I can just swap these 2, right? Except there's no room. Okay, move this here. Kind of reminiscent of the last problem, right? When you needed to swap 2 variables, but there wasn't space. I need to swap 2 of this game's stupid things, and there's no space. Now it doesn't fit, and I can't fucking rotate it. Okay. Just chill. What would be an easy fix to this? Like, rotate it, obviously, but I can't. If I try to build it by hand, I'm going to mess it up somehow. So let's just leave this here and then build it rotated by hand. I always grab this when I mean to grab the bit creation. Okay, so that. We have on the left branch, we do this. We combine them here, and then we just wire it up. Oops. Better? What kind of psycho test things bottom to top, I ask you? Ah! Zero, zero, one. Okay, that's correct. 1, 0, 0. Okay, this should actually be right. Great. Good work on identifying the defective devices. Who would have guessed the supplies from Bob's Bargain Bit devices would be so unreliable? Yep. Great. So what's up with these bonus levels? Do you hear the news? Binary addition is yesteryear. Now we're doing binary multiplication. Yep. I'm not doing this. I've implemented multiplication in games like this before, and I don't want to do it again. Giving you 2 4-bit numbers to multiply. XORing 2 4-bit numbers, that's one thing. Multiplying is much more complicated. I haven't done it very many times in games like this, but I have done it. Inbox? What is all this? Oh, these are just for completing each little section? Fine. I still think I need to know more about how, this game's mechanics work before I do quantum stuff. I mean, I'm sure I could do the easy quantum ones, but I don't know. Strict equality. There are sequences of 8 bits. Okay. Well, I did say the XOR is not so bad, right? This is the opposite of the XOR. It's the XNOR, right? Equality is the inverse of XOR. So XNOR is kind of a funny word you can use for equality if you want. So we have to... Are there exactly 8 bits in each of them, or am I supposed to break the input into 8-bit chunks? Okay, there are actually only 8 bits. And I'm supposed to produce just a single 0. Got it. So you want to compare these bits pairwise. And if you ever get a 1, well, if you ever detect that they're different, you output a 0. And if you run out of bits, you want to output a 1. But there's not a good way to detect that you've run out of bits. So you might need 8, to handle the 8 separate cases separately. Well, but you can't, because they come in on the same wire. So... maybe I should simplify this problem. Because one thing you can do is combine these 2-bit streams into a single bit stream, which is their successive XOR, basically. Whether each of them is equal bitwise. And that's very easy. We've done that before. In fact, I could just do this. So now I have a stream that contains ones and zeros, and I just want to know, is there a 1 in there? Right? Oh, I need to make... oh, not here, but here, actually. So this one must have a 1 in it somewhere because it's telling me the output should be 0. There must be one position where they differ. Let's just confirm that. Looks like it's this one. Yeah. So I'm thinking we want like what do I want? If we ever detect a 1, we can just release a 0. I mean, oh, what's my goal? Don't use any delays. I wasn't planning to, buddy. Although I can see why you might think I would. That would have been an interesting idea. Now that you mention it. But I think I can just do like 8 of these, right? Is that true? No, this doesn't make any sense. No, this doesn't make sense. Because I need to test each of these bits, and they're going through this. They're all going to go through this one guy if I do it this way. Having all 8 of my bits go through 8 control things each doesn't make a lot of sense. Now I can see why you might want a delay gate. Can you configure these guys? No. But you can configure one of these. So I could send a 0 in. Well, no, I don't want one of those. I would want one of these. I could send a 0 in and send it through this like 8 times somehow. That would be my dream. No, that would not make any sense. I would be counting whether there's an even or odd number of mismatches. I don't want that. I want to count whether there's one or more than one. So, but I could send a 1 and pass it through a reset to 0 8 times. That would do something. Now, how to do something 8 times is still not at all clear, but if I could do it, that would solve the puzzle. So, I don't think this is the right idea. I think, like, I want 8 control gates controlling a couple things. Where like if I have a 0 floating around up here somewhere that's like what I'm going to output if none of these are a problem. And then if any of them are a problem, so like, and it keeps getting blocked by controlled splitters. And if one of them is a 1, then it throws away the 0 I was planning to output. And then if none of them are a 1, or the 1 it was planning to output? Okay. 1 if they're identical, so there are only 0s here. Yeah. So, I think that sort of makes sense. If I have... like in the 0 state, we just keep outputting to the right. Like this. But now, the problem is, if we don't have something to actually keep sending here, this doesn't make any sense. This is crazy. Because I don't have 8 separate bits here. I have all my bits 8 times. So, like, how do I run a loop 8 times? Suppose I looped this around into itself, right? I could... connect this up and run all 8 bits through it. That's fine, right? Something like this would let me make a decision 8 times. But how would I know when I had made 8 decisions, is my question. Because that's when I need to output something if I haven't already. I guess it wouldn't be one of these. It would be like one of these. I need... this to... like... to loop back around to this so that when all 8 of them are done, I can release this somehow. But how do I do that? Maybe, like... Can I run a little tournament for these guys? Where like once two of them pair off and one of them deletes itself, but the other one advances, right? And then once that little tournament has happened enough times, right? Maybe? If I could have one of these things that like toggles its state every time. I don't think I... well, I couldn't I? What? This idea seems kind of crazy, but like, yeah. What if you had something like this? They can't be next to each other because of space problems, I guess. But if we took a bit creator here in alternating mode, oops. Yeah, this doesn't work. Yeah, okay, they have to be further apart. That's plenty of space, surely. Okay, they don't need a ton of space, but like that, maybe? So this, I think, if 1 is go straight and 0 is turn right, I think this counts to 8. It throws away the first 7 inputs and then lets the 8th through. Oh, well, there's nothing here, so nothing happens. So I want to put a 1 in here, I think. You don't... Has to be a 1, not a 0. So what does this do? So here's our first bit. It's a 0. It's going to get thrown away. But then it makes it through round 1 and loses in round 2. The next one's going to lose in round 1. But then we get somebody who makes it through rounds 1 and 2, but loses in round 3. This is cute. And that's the 8th bit, and it's finally going to get through to here. Oh. But this guy... He needs to not line up for this, even. Okay, well, fine. Don't throw these away. Let them go to feed into the control part of this loop. Right? We'll set this bit to 0 no matter what it was on the way in. So we're going to get a bunch of zeros. And then only at the very end, we turn one of them into a 1. Right? I guess these are three-way splitters. I don't actually need this many of them. So we're going to let in 7 zeros and then a 1 to here. Which will... Oh, that doesn't work. I need to have a straight line for the control bit thing. And then space for a 0, huh? Like this? Yeah. No, it doesn't come out that way. Well, it should, though. We can recycle this. And in 0 state, it should go like this, continue the loop. But in 1 state, it should escape the loop and be output. Right? I think this makes sense. Let's see if this does something. So our 1 goes around and around in a loop, and if it ever detects another 1, it turns itself permanently into a 0. But it can't go into the next state of the loop until it receives the go-ahead that like someone has made it through. And it's able to go twice here because 2 digits were waiting, but that's fine. And there's a 1 at the very end. How rude. Oh, I guess there was a 1 earlier at some point as well. This 1 was turned into a 0. So all of this looping is kind of pointless. We know what the final result will be. It's 0. But we don't know it's pointless because we didn't design that. Ah! This was supposed to be an invert. Oh my god. Okay. You are released. Go be output, please. Yep, we're outputting 1s and 0s correctly, so I think this is correct. It took me forever to come up with this idea, but like, when you look at it, it's very... In hindsight, it's like, oh yeah, of course, this is a 7-bit counter because it's 3 bits that toggle. But like, figuring out how to... I don't know. It didn't occur to me to do it that way until I had this idea of like, how could you narrow down 8 things to 1 thing? Well, a tournament bracket is what occurred to me, right? Just arbitrarily choose a winner and a loser at each step. And this wasn't actually the first idea I had of how to implement a tournament bracket. I had in my mind, before I was able to vocalize it, this idea of like, what if we had like, I don't know if this even works, but I had this, I don't think it does, this idea of actually physically building the bracket structure like this with sync gates, or maybe output, like these things controlling each other. But it doesn't make sense because I can't actually get the 8 bits. Oh, there's got to be more syncs down here. You can't actually get the 8 different inputs to go to different places. The whole point of this was to figure out how to move one input to a different place. So if you could get your 8 bits to all go to 8 different places, this would kind of be a cute way to know when all 8 of them were done, right? You could just like put recyclers here and here and here and here and here. No, that's too many. 1 recycler on each. Maybe that's right. Yeah. 1 recycler on each sync gate, I think makes sense, doesn't it? Yeah. And then another one here. Wire these up to this. Right? Like that could work if you could somehow construct 8 different inputs to this, which I don't know, I didn't, but that was my first thought for how to do this. And then it's like, oh, well, actually alternating control bits, because these are the only ways that I know of to take input that comes in on a straight line wire and send it to different places. So you need these, and then you need some way to send them to different places, which is control bits. And the way to actually make them different is with these guys. And once I finally had that idea, it's like, oh, if I just have 3 of them that toggle, eventually they'll all line up to the exit. But before that, they'll all line up to not the exit. Okay, that's cool. I like that. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.